Hello all, I am Shatabdi Acharya from Vedang Institute of Technology. So in the previous lectures we were dealing about isomers, homologous series and nomenclature of cyclic compounds. In this video we will be dealing with the chemical properties of organic compounds. Chemical properties of organic compound. So in chemical properties of organic compounds, we will be dealing about some basic or broad classification of chemical properties of organic compounds. But when we will be taking up like functional groups in detail, then we will dive deeper into this chemical properties. Okay. So for organic compounds, chemical properties are broadly divided, or chemical reactions are broadly divided into certain categories. For the first one, we will be taking up combustion reaction. Combustion reaction. So, what do you mean by combustion? In general, combustion means burning something. Okay. So, for burning, we need oxygen. Oxygen is a supporter of combustion. We have like learned this since our childhood. We have learned oxygen is a supporter of combustion and carbon dioxide is a inhibitor, like it stops the combustion, stops fire. That's why in fire extinguishers we are having carbon dioxide gas. Okay. So oxygen is a like supporter of combustion. Okay. So what do you mean by combustion? Combustion means burning of something, and in the language of chemistry we can say reaction of any compound with oxygen. Okay. That is called as combustion. So if I am taking up, suppose for example, any hydrocarbon, let us take methane. When I am taking methane, I am burning it in the presence of oxygen or air. Air contains majorly oxygen. So whenever it, suppose in any cases you encounter a reaction like it is written CH4 plus air, you will simply take up oxygen. Okay, air means oxygen. So if methane is reacting with oxygen, then what products you will get? It will burn to give out carbon dioxide and water. Okay, methane burns to give carbon dioxide and water. Basically, all the hydrocarbons, they burn in the presence of oxygen to give carbon dioxide and water. This is a cheat code for organic compounds combustion. If I am saying methane C2H6 plus oxygen, they give rise to carbon dioxide plus water as well. Okay, but okay, this was the general reaction for hydrocarbons. But the point you have to note here is whenever you are burning something, there is flame. Okay, so by simply looking at the flame, you can say whether the compound is a saturated hydrocarbon or an unsaturated hydrocarbon. How? So we all have seen gas stoves in our house. We all have encountered. So whenever we are burning the gas stove, we are basically seeing a blue color flame, right? A blue flame coming out, and we all have lighted in any like part of our life. We have lighted the diyas for like the Diwali or something, or the candles which we all have seen, right? So the diyas or the candles, they burn with a yellow flame, right? So both we are burning the gas stove as well as the candles also. But why the color of the flame is different? This is because the presence of different organic compounds in them. So broadly, the combustion we are classifying into two categories. One is combustion of saturated hydrocarbons and combustion of unsaturated hydrocarbons. So in the gas cylinders or the gas stoves which you are burning, the gas stove, the LPG which you are saying, whose main composition is ethane and methane type of gases, and ethane and methane are coming under the category of alkanes, which is saturated hydrocarbons. They are burning with a blue flame. So we can conclude saturated hydrocarbons, they burn with a blue flame. Okay, or saturated hydrocarbons impart a blue color to the flame. Okay. Now if I say by that logic, unsaturated hydrocarbons, they will obviously give the opposite reaction. That is, unsaturated hydrocarbons impart yellow color to the flame. Okay. Unsaturated hydrocarbons impart yellow color to the flame. What is the difference between yellow and blue flame? Okay, see, we are basically using LPG for heat or light. For cooking, so we need basically heat. We are not concerned about light. So by that logic, remember, blue flame has more heat content than light. Okay, blue flame is having more heat content than light. Similarly, yellow flame will have more light content than heat. Okay, so saturated hydrocarbons, they burn with a blue flame which is having higher content of heat. Unsaturated hydrocarbons, they burn with a yellow flame and they are having higher content of light. Now you see, whenever we are burning candles or diyas, if you place a piece of paper or something on its top, that turns out to be black. Okay, basically there is some black suspended particles coming out from that burning of that unsaturated hydrocarbons. So we can say unsaturated hydrocarbons burn with a sooty flame. Okay, unsaturated hydrocarbons burn with a sooty flame, the black color which you are seeing. Okay, so unsaturated hydrocarbons burn with a sooty flame. Now if I say unsaturated hydrocarbons, they burn with a non-sooty flame. Okay, so what we concluded, saturated hydrocarbons, they burn with a non-sooty blue flame and they have more heat content than light. Whereas unsaturated hydrocarbons, they burn with a sooty yellow flame and they have more light content than heat. Okay, so this was all about combustion reaction. The next category of reaction which we are dealing up in organic reaction is addition reaction. Okay. So if we see organic reactions, you don't have to use rocket science for those reactions. Simply the name of the reaction carries its meaning. Okay, combustion means burning and we will burn in the presence of air, right? So the combustion reactions basically deals with reactions of hydrocarbons with oxygen. Now if I am saying addition reaction, the second category, addition reaction. Okay. Now addition reaction means we have to add something. So to which place we can add, which is having some space or deficiency, then to that place only we can add. So if I'm saying saturated and unsaturated hydrocarbons, saturated hydrocarbons, they were all satisfied with a single bond. But unsaturated hydrocarbons, they had double and triple bonds as well. So I have said single bond is very strong bond, like sigma bonds are strong bond, but pi bonds are weaker bonds. So in case of double and triple bond, they are having one single bond and 1 and 2 pi bonds respectively. So obviously it will be easy to break the pi bonds. Therefore we can add or we can undergo addition reaction only in case of unsaturated hydrocarbons. Okay, saturated hydrocarbons, they are already full. They have no place in their stomach to take up food further. Okay, we cannot add anything more to already saturated hydrocarbons. Saturated means they are satisfied. Their valencies are satisfied. They cannot take or they cannot form bond with any atoms further. But in case of unsaturated hydrocarbons, they are half full. They have the tendency to take up atoms by breaking the pi bonds. Okay. So addition reaction can only be undergone for unsaturated hydrocarbons. They are never shown by saturated hydrocarbons. Okay. Now, if we see an example, let us take an alkene. If I'm taking an alkene, CH2 double bond CH2, okay, and I'm adding a hydrogen to it. Okay, for adding hydrogen, I need a catalyst. Now, what is a catalyst? Catalyst is any chemical substance which increases the rate of reaction without itself undergoing any chemical change. Okay, it will simply increase the rate of reaction and it will be like extracted at the end of the reaction unhampered or unchanged. Okay, it in itself will not change its property or undergo any chemical reaction. It will simply increase the rate of chemical reaction. It will make the rate of reaction faster. Okay, so if I see this like alkene, which is ethene, and I'm reacting it with a hydrogen in the presence of a catalyst, let's say nickel, or I can use palladium also as a catalyst, okay, or platinum also. Basically, I'm using those metals, those are in itself non-reactive, okay, they cannot undergo reaction, otherwise they will not be like, they will act as a catalyst, but they will also undergo chemical reaction which deviates from the property of catalyst. They will like catalyst, an ideal catalyst should not undergo or should not react in the process of chemical reaction. It should just increase the rate of reaction. Okay, therefore we are basically using noble metals or non-reactive metals as catalyst. So what happens if I'm reacting ethene with hydrogen? Then this bond will break. Okay, this pi bond will break, assuming the first one to be a sigma bond, the next to be a pi bond. The pi bond will break, and what we will get? CH2 bond CH2, and to satisfy its covalency, or sorry, tetravalency, hydrogen will be added to this carbon, and this carbon we will get CH3 bond CH3. Okay, similarly, I can take an example of alkyne also. CH. I can add hydrogen in the presence of any catalyst, let's say nickel, then it will form CH2 double bond CH2. Okay, I'm adding 1 mole of hydrogen, that means it will break only one bond and there will be addition of 2 hydrogen atoms to the 2 ends of the carbon atoms. So here I will get CH2, CH2. Now if I further add another hydrogen molecule, because here still I am getting an unsaturated hydrocarbon, right? It has still the scope of breaking another pi bond, or another weak bond, which is pi bond. So if I am adding another H2 molecule to it, in the presence of catalyst nickel, I'll get CH3, CH3. I cannot break it further because I have reached the ultimate condition where I am having only a single bond, and sigma bonds are difficult for breaking. So I cannot hydrolyze it further. So, if I am adding, the process of addition of hydrogen to a bond is called as hydrogenation only and only if one unsaturated compound is changing to a saturated compound. If by the addition of hydrogen, I am converting an unsaturated compound to a saturated compound, that process is called hydrogenation. This process is called hydrogenation. Which means addition of hydrogen. Okay, hydrogenation means addition of hydrogen in the first case. If I say in the second case, here I am converting a alkyne into alkene, but still it is unsaturated. So this process is not called hydrogenation. But from this step to this step, when I am getting a alkane, a saturated hydrocarbon, this step is called as hydrogenation. And we have a physical application in our day-to-day life, a physical significance of this reaction, well, like the process where we are converting vegetable oil. If we are converting vegetable oil to ghee, we are undergoing this process. By hydrogenation, we are converting vegetable oil to ghee. Okay, so this was all about addition reaction. The next reaction which we encounter here is substitution reaction. Okay, now what do you mean by substitution? Substitution means the place is already full, but we have to accommodate someone new. So what we have to do? We have to pick one old member out, and in place of that member, we are placing another atom. Okay. So here what we have done, in addition, we have seen that addition reaction are only and only shown by unsaturated hydrocarbons, right? But in case of substitution reaction, we have to see those category of molecules or those category of compounds, those are already full. So what compounds are already full? Saturated hydrocarbons. So substitution reaction is only shown by saturated hydrocarbons. Okay, saturated hydrocarbons only undergo substitution reaction. Suppose I'm taking an example, CH4, methane. Now what I will do, I will impose sunlight or UV light to it, and I will add a chlorine molecule. Okay, I will react this methane with a chlorine molecule in the presence of sunlight or UV light. What I will get? One hydrogen will be substituted by one chlorine atom, and we have one chlorine atom and hydrogen atom left. So they will combine among themselves to form HCl, hydrochloric acid. And in the process, what I'm getting? CH3Cl. So to name this compound, this will be chloromethane, because I have derived it from the parent compound methane, right? So the name becomes chloromethane. Now I have 3 more hydrogens still left. So following the same reaction condition, I can substitute these hydrogen atoms also. So in the second step, what I can do is, I will take this chloromethane which I have obtained, I will react it with another chlorine in the presence of sunlight or UV light, and what I will get? Another molecule of hydrogen will be substituted by the chlorine atom. So the reaction will become CH2Cl2 plus HCl. And what compound I will be getting? Dichloromethane. Okay, I'll be getting dichloromethane. Now if I see the third step, CH2Cl2 will react with chlorine under same condition. It will form CHCl3 plus HCl. Now in this step, it forms a very, very, very important compound for organic chemist, and you all must have heard about it. If I see the IUPAC name, it will be trichloromethane, right? But its common name is chloroform, right, which we all have heard about. Okay, it is basically used for making people unconscious. So we get, in this step, we get one compound which is trichloromethane, which is known as chloroform. Next is, in the fourth step, I still have one more hydrogen atom left, and I can substitute that also. So basically, if I react CHCl3 with Cl2 under similar conditions, I will get CCl4 plus HCl. Here I will get tetrachloromethane. Sorry. We'll get tetrachloromethane. Okay, so this is basically a chain reaction. It is occurring in a stepwise manner, in a chain, one step leading to the other. So in chemistry, we have a very beautiful name for this, which is called as free radical substitution. Free radical substitution, about which we will be learning when we are digging deeper into organic chemistry. But for now, remember, it follows a free radical reaction mechanism. Okay, so this was about substitution reaction. The next category of reaction which we can see is elimination reaction. Okay, so elimination in general means removing something. Okay, so if we try to remove something, from what compound we'll be removing? One that is having, which is almost full. Okay, so basically elimination reaction is also shown by saturated hydrocarbons. Okay, saturated hydrocarbons show elimination reaction. For example, if I'm saying I'm having CH3, CH2, OH. Okay, so here from this compound, if by any means, if I'm giving a base OH minus under basic condition, what will happen? A hydrogen from this carbon atom and the OH group from this carbon atom will be removed out as water As a result, what will happen? A bond will be formed between these two carbon atoms in order to maintain its tetravalency. So what you will get here? CH2 double bond CH2. Okay, so if you have to convert a saturated hydrocarbon to an unsaturated hydrocarbon, you can basically use the process of elimination reaction. And the elimination reaction where you are removing a water molecule is called as dehydration. These category of reactions are called as dehydration reaction. Dehydration means removal of water. Okay, so this category of reactions are called as dehydration reaction. The last category, it's not the last, but probably for you it's the last, but when we'll be dealing with the chemical functional groups in detail, then in those chemical reactions we will take up individual reactions as well as their mechanisms also. Okay, so the last is oxidation reaction. I guess this is the fifth one. Oxidation reaction. Now, what do you mean by oxidation? Oxidation basically means addition of oxygen. Okay, so if we add oxygen to a particular organic compound, then we get the reaction under the category of oxidation reaction. For example, if I'm saying CH3, CH2, C double bond O, H. This is our aldehyde. Okay. If I'm adding an oxidizing agent which is KMnO4. Okay, remember this is KMnO4 is a oxidizing agent. Okay. Alkaline KMnO4. KMnO4 in basic condition. So if I'm adding alkaline KMnO4 to this, or K2Cr2O7 also, KMnO4 is called potassium permanganate and K2Cr2O7 is called potassium dichromate. Here what happens? Manganese and chromium, they are in the highest oxidation state. Okay, manganese is having oxidation state of +5 and chromium is having oxidation state of +6, I guess. So here they are already having, or they are already present in their maximum oxidation state. So how oxidation state is achieved? By the loss of electrons, and loss of electron is called as oxidation. So what happens? After losing their maximum number of electrons, they won't be capable of losing any electrons further, but now they have the capability of gaining electrons, right? So by gaining electrons, they themselves undergo reduction and they oxidize the one from whom they are taking up the electron. That's why in the process they are acting as a oxidizing agent. So here KMnO4 and K2Cr2O7, basically those compounds where the central atom is in their maximum oxidation state, those elements or those category of chemical compounds act as oxidizing agent. Okay, so here KMnO4 and K2Cr2O7 act as oxidizing agent. What they do? They basically add up one oxygen to this aldehyde, and if we are adding an oxygen atom to aldehyde, then we will get the next higher functional group, which was CH3, CH2, COOH. Okay, aldehyde is getting oxidized to carboxylic acid. Okay, so always remember, if you are having an alcohol and you try to oxidize it, I'm adding I'm simply writing nascent oxygen to show oxidation. So if I'm adding a nascent oxygen to alcohol, it will be converted to the next higher functional group, which is aldehyde or ketone. And this on further oxidation will form a carboxylic acid. Okay. Now, if I'm adding a very strong oxidizing agent, that will directly convert this alcohol to the carboxylic acid. If I'm adding a strong oxidizing agent. Okay. So this was all about the chemical reaction shown by organic compounds, and these are the basic or the broader chemical reactions. We will take up each chemical reactions and the mechanisms involved in them in the later classes as we deal with individual functional groups in detail. Okay, thank you so much for the video. Thank you.